Envision a star that passed close by the Earth and changed the entire tapestry of the planet, leading to a deadly effect. According to the researchers, several million years ago, one star made Earth experience a dramatic shift in climatic and orbital dynamics. But the question is, how much worse did it make the situation? Researchers believe that a star had passed by our solar system 56 million years ago, which had caused severe changes in the eccentricity and inclination of Earth and other major planets like Jupiter, Saturn, Uranus, and Neptune. There's a study that was published on the 14th of December 2024, in which the authors have explained the effects of passing stars on the orbital history of the solar system with the help of computer simulations. This study was a result of curiosity about whether passing stars could affect the vast solar system and have a hand in the rapid global warming. Now, in the study, there are terms like PETM, that stands for paleocene-eocene thermal maximum, which was a time period of a few million years where the Earth's temperature had risen by 8 degrees. This dramatic change had several effects on the Earth's biosphere, where new species were rapidly growing and many existing ones went extinct. As we mentioned before, eccentricity and inclination were one of the main subjects that the researchers focused on. Now, eccentricity is the measure of how elliptical the Earth's orbit is, and the inclination is the measure of how tidal the orbit is. Now, these measures have an effect on how solar energy is received and distributed, so automatically it influences the climate. After running several tests, researchers found out that a starry encounter like this could have in fact happened, affecting the major outer planets like Jupiter, Saturn, Uranus, and Neptune, and the effects of these were shared to the inner planets with gravitational interactions. They also found out that the probability of such encounters happening in the last 100 million years is actually 1 in 10,000. The study holds immense strength in its novelty and the creativity that it has, as it is the first ever study that was done to understand the effects of passing stars in the solar system and the orbits of different planets. The researchers also tried to link it with the PETM, trying to find another possible reason for the rapid global warming. It's also the very first study to use realistic and rigorous simulations to understand the interactions of the solar system, and thus it pushes us to think out of the box when it comes to understanding Earth's orbital history. The study also has its own cons as well, since it was done with the help of computer simulations based on mathematical models and assumptions, and no real interactions. It's difficult to replicate the actual incident, which might have occurred, and leaves the researchers with a possibility, not a fact of true occurrence. The uncertain conditions and properties of the stars might also have an impact on the entire scenario, so it leaves with the conclusion that the study cannot prove if such a starry encounter ever really happened or not. The study also misses out to bring clear points as it acknowledges the various other factors like the tidal forces, comet occurrences, and others, but fails to relate them to their own findings, which means it was unable to capture the entire dynamic of the incident. Now, to understand how the study adds to our previous knowledge of Earth's orbital history. Since we have a guess about the star passing by, we now have another reason for the PETM, which was one of Earth's most extreme cases of global warming, and now this also leaves us with uncertainty as to what might happen in the future, since a passing star could affect the Earth so drastically. Now, for example, if there's a higher eccentricity, there will be increased contrast between the seasonal changes, and a higher inclination can change the distribution of sunlight between the hemispheres. But not to confuse that this might be the only cause of PTM, and there are several other possible contributions to the ancient warming history, such as volcanic eruptions, asteroid interactions, or the changes in the ocean beds. That brings us to the end of this dynamic interaction of stars and the solar system. But did you know that NASA has discovered something unusual lurking below Mars' surface? Click the video right on the screen to find out more.